Hidden technologies of World War II. The Enigma machine and cryptography. The Enigma machine wasn't the only cryptographic device of importance. The Germans also used the Lorenz cipher for high-level communications. British codebreakers at Bletchley Park developed the Colossus, the world's first programmable electronic computer, to crack this cipher. This breakthrough in computing remained classified until the 1970s. Acoustic torpedoes. The Germans developed acoustic torpedoes that could home in on the sound of ship propellers. The T-5 Zaunkönig torpedo was particularly feared by Allied ships. To counter this, the Allies developed noise-making devices called Foxer to decoy these torpedoes away from ships. Proximity fuses. The development of the proximity fuse, which detonated explosives when near a target, was a closely guarded secret. This technology dramatically improved the effectiveness of anti-aircraft guns and artillery shells. It was so secret that it wasn't used over land until late in the war, for fear that unexploded ordnance would reveal the technology to the enemy. Synthetic rubber and fuel. With natural rubber supplies cut off, the Allies developed synthetic rubber on an industrial scale. Similarly, Germany, lacking oil resources, developed processes for creating synthetic fuel from coal. These advancements laid the groundwork for modern petrochemical industries. Submarine technology. Advanced submarine technologies were developed, including the snorkel, which allowed submarines to run diesel engines while submerged at periscope depth. The Germans also developed the Type 21 U-boat, which was far more advanced than contemporary submarines and influenced post-war designs. Biological and chemical weapons. While thankfully not used on a large scale, both Axis and Allied powers developed advanced biological and chemical weapons. The UK's Porton Down facility worked on anthrax weapons, while Japan's Unit 731 conducted horrific experiments with various pathogens. Radar countermeasures. Both sides engaged in electronic warfare to counter radar. The Germans developed Metox receivers to detect Allied radar emissions, while the British used window chaff to confuse enemy radar systems. Additional advancements gained from the war. Nuclear technology. The Manhattan Project not only led to nuclear weapons but also paved the way for civilian nuclear power and advancements in physics and materials science. Pressurized aircraft cabin. The B-29 Superfortress was the first mass-produced pressurized aircraft, leading to more comfortable and efficient high-altitude civilian air travel. Blood plasma. The development of blood plasma as a substitute for whole blood transfusions saved countless lives during the war and continues to be crucial in modern medicine. Synthetic materials. Beyond nylon, other materials like Teflon were developed during the war. Teflon was initially used in the Manhattan Project but later found numerous civilian applications. Miniaturization. The need for smaller, more efficient equipment in aircraft and submarines drove advances in miniaturization, setting the stage for modern electronics. Operations research. The scientific approach to decision-making and resource allocation, developed during the war, became a standard practice in business and government. Cybernetics. Norbert Wiener's work on automated targeting systems led to the development of cybernetics, influencing fields from computer science to biology. Rocketry and jet propulsion. Beyond the V-2, other advancements included the first cruise missiles, V-1, and jet aircraft like the Me-262. These technologies revolutionized both warfare and civilian transportation. Radar application. Post-war, radar found numerous civilian applications, from weather forecasting to air traffic control and even microwave ovens. Cryptography and information theory. Work on code breaking led to advancements in information theory, influencing modern digital communications and data compression techniques. The hidden technologies of World War II not only influenced the immediate outcome of the conflict but also had far-reaching effects on scientific research, industrial processes, and everyday life in the decades that followed. Many of these advancements form the technological foundation of the modern world.